In this lecture, we're going to talk about perfect competition and how firms make decisions in perfect competition. So first, we'll review what it means when a market is competitive and perfectly competitive. Then we'll talk about how firms operate in perfect competition. How do firms make decisions about how to maximize their profits? And then, what does the supply curve look like in a perfectly competitive market? So just to review, we talked about this before, but perfectly competitive markets are markets where there are many buyers and many sellers. The sellers are selling goods that are very similar, if not identical. There's free entry and exit for the sellers, very easy for sellers and producers to enter the market, very easy for them to leave the market. And what that means is that firms are price takers. So each individual firm has no control over the market price. Each individual firm just looks out, sees what the market price is, and that's the price that that firm charges. So a firm living in perfect competition has the goal of every other firm, trying to maximize your profits. And if you're a firm trying to maximize profits, you need to consider revenues and costs, since profits are revenues minus costs. So we can think about firms considering different different aspects that firms would consider. If firms are going to consider revenue, revenue is price times quantity. So things that would change revenue are how many units are sold, what price is charged per unit. Firm also considers its costs, and then its profit is going to be its total revenues, it's TR, minus its total costs. So if a firm is trying to maximize its profits, this is something that will hold true for other types of market structures that we will talk about later. But firms need to consider what's called marginal analysis and marginal thinking. So remember, whenever I say margin, you should think of change. So the first marginal concept we're going to talk about here is marginal revenue. This is basically how much revenue a firm can get if it changes its output a little bit. So marginal revenue, the math definition is you take your change in total revenue and you divide it by your change in quantity. That gets you your marginal revenue. And for a competitive firm, this is really important, marginal revenue is always equal to price. So if you're a price taker, then you basically have no control over the price, just market price. So every additional unit you sell, you get the market price. So that's easy to remember. Your marginal revenue, perfectly competitive market, is just the price. Marginal cost has a similar definition. It is the change in a firm's total costs for changing quantity. So you can think about marginal revenue as if you decide to sell a little bit more, how much will your revenue change? You decide to sell a little bit less, how much would your revenue change? Marginal cost is if you decide to sell a little bit more, how much would your costs change? If you decide to sell a little bit less, how much would your costs change? So if you put marginal revenue and marginal cost together, you get that these two things, subtracting off marginal cost from marginal revenue, gives you the change in a firm's profit from changing its production a little bit. So if you put these things together, you can see that firms will maximize their profits by choosing an output level such that marginal revenue is just equal to marginal cost. So why is this? Well, let's think about if this was not true. Let's say that we're producing some quantity where marginal revenue is greater than marginal cost. Well, that would tell me that if I produce just a little bit more, the revenue I would get from producing just a little bit more would be greater than the cost that I would incur producing a little bit more. So if I produced a little bit more, I would increase my profits. If the opposite is true, my marginal revenue is less than my marginal cost, then if I cut my production a little bit, I would maximize my profits. So if I wanted to show this analysis graphically, here I've got my average total cost curve from last lecture, and here I've got my marginal cost curve. And remember, my marginal cost curve crosses my average total cost curve at the minimum possible average total cost. Now I can figure out what my profits are going to be based on the market price. So here the market price is $10, and the quantity that I produce is I want to find a quantity along this axis where my marginal cost curve is equal to my marginal revenue curve. So I find the place where these two things cross, I trace this down, and this is the quantity that I should produce to maximize my profits. So how can I visually display my profits here? Well, it turns out that what I can do is then take this quantity and find where it crosses my average total cost curve, trace that quantity over to where the price is. Well, here the average total cost is $8.75. So then this rectangle here is a representation of my profits. Now, if this happened to be at a price where I was losing money, then this rectangle difference between the price and the average total cost times the quantity would also be a representation of my loss. But here, this rectangle, price minus ATC times the quantity, this rectangle here is a visual representation of my profits. So you could think about that rectangle in the sense of this equation right here. So the length of that rectangle is the quantity, so that's my units sold, and then the width of the rectangle is my average profit per unit. So multiply those two things together, and that gets me my total profit or my total loss. Right now we're talking about the short run, and recall in the short run, I can't always decide to go out of business totally because I can't change my fixed costs. I can change my variable costs, and I can't change my fixed costs. So sometimes firms will decide to shut down in the short run. So if you can't make a profit, firms may decide that it's worth it to shut down in the short run. So classic examples are Aspen ski resorts shutting down, beach towns, restaurants in beach towns being closed for the winter, and this is not necessarily the same thing as going out of business. This is shutting down temporarily when it's not worth it to stay open. So we can see graphically when it would be worth it for a firm to shut down versus stay open and take a loss. So here are our cost curves from before. And first what I want you to look at is these specific prices right here. So note that $2.50 is my minimum possible average total cost. So here, if the price happens to be $2.50, then the quantity that I produce is right where I'm crossing my marginal cost curve. And notice that here, my profits would be 0 because my price is exactly equal to my total costs. So on average, I'm making $0 in economic profits per unit, so I make $0 of profits. So anytime that the price is above this point, the minimum point on my average total cost curve, the firm is going to earn a profit. Now what about this area down here? So notice that $2 is the minimum possible point on my average variable cost curve. So what happens if the market price is below $2? Well, that indicates that at that price, I'm already eating my fixed costs. Can't do anything about my fixed costs. I have to spend that money no matter what. But I can't even make enough money to meet my variable costs. So I lose less money if I temporarily shut down than if I stayed open. So anytime that the price is below the minimum average variable cost, which is right here, right where this line is at its minimum, anytime the market price is below here, my best option is to shut down. I lose less money by shutting down than I do by staying open. This middle rectangle in here shows possible market prices where I would still stay open and incur a loss because I would be losing less money than if I shut down. So I'm losing money because I have my fixed costs that I have to pay no matter what, but I make some of those fixed costs up by opening. So I still want to open, but I'm going to lose money. So you can summarize all of this in this nice little table. Whenever price is greater than average total cost, then I'm going to make a profit. Whenever price is between the minimum average total cost and the minimum average variable cost, I'm going to stay open, but I'm going to lose money. And whenever price is less than the minimum possible average variable cost, then my firm is going to shut down. So I can put this all together to derive a supply curve for my firm in the short run. So let's just draw our cost curves again. So here are my three areas of making a profit, making a loss, and shutting down. So as long as the price is above the minimum average variable cost, I'm going to be open for business. And the quantity that I produce for any given price is going to be equal to the quantity that would be given by my marginal cost curve. So let's say the price was here. So if the marginal revenue curve crossed right here, then quantity that I produced would be given by where this horizontal line crossed the marginal cost curve, so I'd go down. So I could just trace this line up, and that would be my individual firm's supply curve. Well, below the minimum average variable cost here, my firm's going to decide to produce nothing. So my supply curve is going to start at 0, go up to the minimum possible average variable cost, and then kind of jump over here and trace up the marginal cost curve.